Okay, so I'll demonstrate the ultrasonic sensor part of the lab. So as we can see here, I have set various values for our timer. So the timer is going to be sending pulses to our trigger, and then the serial is going to be reading the echo and calculating the distance based off that. Here we can see that I've set it into fast PWM mode, and I've also set the prescaler to 1024, which allowed me to increase the delay between signals by a lot. I found a value of 500. It was a little difficult deciding on values. Sometimes a lower value would produce a slightly higher delay, and then you get to a certain point and it switches and drops back down, makes it very small. But I found with 500, the values here are very, very stable. So I liked that, and that's why I chose 500. As for the 0.1, when the frequency is going to be this high, our duty cycle value, which is affected by OC2RB, that needs to be a very small value so that it only stays high for a very brief period of time. I couldn't get it to drop below about 0.01. So as you'll see on my oscilloscope, the high pulses, rather than being 10 microsecond, they're actually around 50 or 60 microseconds. But again, in this configuration, I have a very consistent output as far as distances, and these may not measure exactly how far it potentially could go, but when I do start measuring objects, it's really good at doing that. So I can demonstrate that now. I've got a large book here, so I'm just going to place this book in front of the sensor here. So we've probably got, maybe 5 inches, 6 inches. And yep, we see 5 inches coming up there. I'm gonna move it back now. It's probably around a foot. Yep, 11 inches. Gonna move it back again, probably 16, 18 inches. Yep, exactly as it says on the monitor. And all these guesses I'm making based on the distance. And so right up beside the desk, maybe 2-3 inches. As we can see, 2 inches. And like I said, it's very, very stable. So it's measuring this really well. As I do it dynamically, you can see it increase and decrease very well in response to the movements. So I think this configuration worked really well for the first part of the pulse, the ultrasonic pulse response. Okay, so now I'll quickly show the oscilloscope for this. As I mentioned before, with a 20 microsecond measurement here, we can see that it takes about 60 microseconds for each of the pulses, and it's hard to get a good reading of how often they come in. But in this mode, we can see, with the 5 millisecond base, we have a frequency of about, 18, 19, 20 hertz. And that converts to around, 52 millisecond period, which is very close to what they recommended. And that's calculating at 90. It goes as low as 18, which is 55, and then as high as 20, so 50. So it's very close to that 50 millisecond cycle. And the cycle they recommend is 60 milliseconds, so it's very close to that as well. Okay, I'm going to demonstrate the pulse width with an interrupt here. So as you can see, I have copied over the code to here to again put it in fast PWM mode as before, and with a 1024 prescaler, 500 for OCR2A and 0.01 for our OCR2B, which A will impact the frequency, B will impact the duty cycle. As we can see from the oscilloscope, we've got a similar output as before, where we've got about a 60 microsecond pulse coming in. And the main difference in this program obviously is the use of the interrupt service routine, which will then speed up the program handling the pulses that we receive. So when I show our serial output, we can see that again, we have very accurate values here, so it's only varying up and down by about 1 from 190, so it goes down to 189 and up to 191, so things are very accurate. As far as the distance that it's measuring, my bed is around 6 feet, maybe just a little bit over, and so it's measuring from a couple centimeters back on my desk, around where the bed ends to my wall, which again, there's some stuff over there, so it might make it a little bit inaccurate. But we can see it's around 74 inches, which I think 72 inches is 6 feet, so it's fairly accurate, adding 2 to 3 inches onto that, which can be expected. So it's working very well now. And using the interrupt service routine, it's handling things very quickly, and again, making these values even more refined and not changing a ton over time, which is definitely a positive for the program. Okay, and to demonstrate the final part, pulse width int with the low level. So the main difference in this program obviously is using low level instructions to indicate when we have a falling edge or a rising edge, and shifting the p-ind values and using those as indications for us. Yeah, we can also see clearing our flags. So everything here uses low-level instructions to again try to make things a little bit quicker to execute. Since we don't use as many high-level instructions, before we were using, as we can see, digital pin to interrupt and attach interrupt and read digital. So these are all high-level instructions that obviously call a certain method or function that has a few lines to execute. So by using the low-level instruction, we make things a lot more efficient for us. As we can see here, once again, as the last time, very, very accurate values, only varying by 1 centimeter usually. And so it stays around 74 to 75 inches, which, as I mentioned before, is accurate for what we would expect. Obviously, since we haven't changed anything with our timers, we have the exact same output here being calculated through our oscilloscope, and so everything still makes sense given what we have kind of worked on over the last couple tasks. One last thing I'll demonstrate for this program is kind of how it changes and how it responds very quickly to objects. So putting this in front, we see the change very instantaneously. So I'm going to place it in front right now. Right away, it starts working and measuring things, and again, very accurate with the values that it's measuring. So it's doing a great job at that. To find the lowest, pull it in, and so you see once we hit that 3 centimeter mark, it just went up a little bit, and so it struggles under 3 centimeters. I think that is because it doesn't do rounding. So I think what's happening is, even though the ultrasonic sensor should be able to go down to 2 centimeters, because it doesn't round, it's probably at like 2.1 something, and it's just not going below that value, and so it won't actually show the 2 centimeter, which I think should be attainable. Also, we can see after doing that, we've changed kind of the max and min value a little bit, making these new changes, and so our new highest and lowest values are around 195, I just noticed. And so again, it's only varying by about 1, but that 195 centimeters, obviously it's getting even more accurate to the distance that I would expect this to be.